Okay, let's continue on with our next example. We've got the mean July daily rainfall in Waterville is 10 millimeters, and the standard deviation is 1.5 millimeters. Assume that the data is normally distributed. What is the probability that the daily rainfall will be less than 8 millimeters? So again, let's just draw a representation of our normal curve here to get an idea of what part of our graph we're considering. This time our mean, we're told, is 10 millimeters, and we're looking for 8 millimeters or less, so we're going to shade in our 8 or less here. So now we're looking for the probability of something falling in that range, so we're back to using our normal CDF, which, if we have, are similarly to our sleep example, if we're looking for a value for our lower boundary that continues on and on and on the left-hand side of our graph, we can just use a number that's very far away from our mean in that direction, which negative 10,000 will still be an appropriate choice here. Then we have our upper bound of 8, our mean of 10, and now our standard deviation is 0.15. So when we plug all of this into our calculator, we should be getting 0.0912, which this time we're asked for a probability, not a percentage, so we're not going to convert here. So we're told our probability is 0.09, which again, that's a pretty small proportion of our graph. So I'd say this looks like we're pretty spot on here, and we can move on. All right, the next example asks us, the ages of a population of a town are normally distributed with a mean of 43 and a standard deviation of 14. What is the probability that someone is between the ages of 22 and 57? So why don't you go ahead and try this one out on your own again, and then pause the video and we can go over our solution when you're ready. All right, let's take a look here. So now let's draw our normal curve. Our mean is 43. We've got it. We're looking between 57 and 22. All right, so we're looking for the range in between our 22 and 57 for our ages, which means we're going to want to use our normal CDF again. With our lower bound of 22, our upper bound is 57, mean of 43, and a standard deviation of 14, which should return the probability of 0.7745. So that's the majority of our graph here, falls between our 22 and 57 years old. I think it looks pretty good. It lines up with what we drew. So should be good here to move on. Now letter B asks us, how many would you expect to be aged between 22 and 57 if the town has a population of 5,000? So we're told 70 or 0.77 of our population falls between that age range. And if our population is 5,000, we can simply take our probability and multiply it by our population here to get us the number of people that fall within that age range. Which when we do so, we should be getting 3,872.5. And when we're considering a real world example like this, where we can't have 0.5 of a person, we're just simply going to round up to the next whole person here. So we'll say 3,873 people. All right, now let's talk about the standard normal curve. So the standard normal curve, that means we're considering when we have a mean of 0 and a standard deviation of 1. And we're still going to be using the same functions on our calculator here, the normal CDF. But now we'll have a lower bound like before. Again, we'll have our upper bound. And now for our standard deviation and mean, we're always going to have a mean of 0, and our standard deviation will always stay 1 for our standard normal curve. Likewise, with our inverse norm, we'll have our percentile, our mean and standard deviation will likewise be 0 and 1. These two won't change. If you don't enter either of these in your calculator, it should assume that they are the standard normal curve. So if you don't enter a mean or standard deviation, your calculator will assume those for you. Now let's do a couple of practice problems here, just looking at our standard normal curve. So now we're given an area in terms of our z-score of z is less than 1.7. So drawing out our normal curve here, we've got our mean of 0 in the middle, and we have a positive z-score, so 1.7 standard deviations above the mean, which we'd be considering a z of everything less than that positive z-score. So we're looking for that region that falls below our 1.7 standard deviations above the mean here. So now we can plug this into our calculator using our CDF, and we'll use our negative 10,000 here for our values that fall below our standard or below our mean here. Negative 10,000 will be far enough away again. Then we'll have our upper boundary of 1.7, our mean of 0, and our standard deviation of 1, which should be returning 0.9554. So that's the majority of our graph falls below 1.7 standard deviations above the mean. Now let's try out a range of z values where we have mean again of 0, and we have a negative 1.4 z value, so that's going to be 1.4 standard deviations below the mean. We have our positive 2.1, which will be 2.1 standard deviations above the mean here, and we're looking for the likelihood that something occurs in between these two z values. So again, let's use our normal CDF. Now we'll have our lower bound of negative 1.4, our upper bound of 2.1, our mean is 0, and our standard deviation is 1, which should be returning 91.58%, or as a probability, 0.9158. All right, why don't you go ahead and try letters C and D on your own, and then we'll see if we can get these same solutions here together. So go ahead and pause the video and work on these next two by yourself, and then you can unpause once you're ready to go over them. All right, let's consider our first example here, letter C. So we've got a mean of 0 in the middle. Now we're looking for 2.14 standard deviations below because we have that negative z-score. and we're saying z is less than this value. So we're looking for the region that falls below 2.14 standard deviations below our mean, which we can use our CDF again to figure out. So let's use negative 10,000 here for our lower bound, everything that falls indefinitely below our point, or on the far end region of our graph. And our upper bound is going to be our negative 2.14 with 0 and 1 for our mean and standard deviation here, which will get us 0.0162. So a pretty small proportion of our overall graph, which makes sense here, because we're only considering all of the things that fall below our 2.14 standard deviations away from the mean, which is already getting pretty far from our mean. So it makes sense that we're getting that small proportion here. Letter D is asking us for 0.92 standard deviations above the mean now. So let's draw our 0.92. And we're looking for everything that falls above that value. So now we'll have our normal CDF. With our lower bound is 0.92. Our upper bound we can say is positive 10,000. Then our mean and standard deviation of 0 and 1, which this is still a relatively small portion of our graph, and our calculator should be returning 0.1788. All right, last example, letter E. What value is above 74% of our data here? So that is just another way to ask us, what is our 74th percentile? So if we're drawing our mean of 0, and then we have our unknown x value here, we're looking for the value at which 74% of our data falls beneath it. So we can use our inverse norm this time. With our lower boundary, or with our percentile of 0.74, our mean of 0, and our standard deviation of 1, which will return a z-score of 0.6433. So at 0.6433 standard deviations above the mean, 74% of our data will fall somewhere in that region. All right, that wraps it up for this lesson. That's all I wanted to cover for today. So I will see you all in our next lesson. Everybody take care for now. See you soon.